right, continuing with our sample test, we're still in the section that tells us to simplify, and we are not allowed to have any negative exponents in our answer. So for number 13, again, let's go through and separate these, group them into like pieces so we can put the 6 over 42, our coefficients, together. Let's put our r's together and our u's together. All right, so 6 over 42 will simplify down to 1 over 7. Both of those are divisible by 6. And then when your bases are the same and you're dividing, remember you subtract your exponents. So that'll be negative 4 minus 4. And then nothing to combine with the t to the negative 8. But we know we're going to have to get rid of that negative exponent by using its reciprocal. So let's go ahead and let's move that t to the negative 8 across the division bar and make it t to the positive 8. All right, and then here when your bases are the same and you're dividing, subtract your exponents. So 2 minus 2. So negative 4 minus 4 gives us negative 8, and 2 minus 2 gives us 0. U to the 0 is going to give us 1, because remember anything to the 0 is 1 other than 0 to the 0. And then we need to get rid of this negative exponent as well. So again, remember we're going to use the reciprocal. So we're going to move this negative 8 across the division bar, and then it becomes positive. So in our numerator, we're going to have 1 times 1 times 1 times 1. And in our denominator, 7 times r to the 8, t to the 8th. All right, for 14, similarly, we're going to group our coefficients. We're going to put our x's together, we're going to put our y's together, and we're going to put our z's together. So negative 8 times 4 is negative 32. When your bases are the same and you're multiplying, you add your exponents. Remember the exponent on this x is x to the 1. So we're going to have negative 5 plus 1 for our x's. For our y's, 4 plus negative 2. And then for our z's, negative 2 plus 2. So negative 5 plus 1 is going to give us negative 4. 4 minus 2 is going to give us 2. And negative 2 plus 2 is going to give us 0. So let's break this apart into separate pieces. So we've got negative 32 over 1. We've got x to the negative 4 over 1. Y squared over 1. And then remember, anything to the 0 is going to be 1 other than 0. So z to the 0 gave us 1. For our final answer, we can't have any negative exponents, so we're going to rewrite x to the negative 4 as 1 over x to the positive 4. And so in our numerator, we've got negative 32 times 1 times y squared. And in our denominator, we've got 1 times x to the 4th times 1. All right, then for number 15, we want to be sure that we simplify inside the parentheses first before we raise this to a power. So I'm going to go through and just work on the inside here. So let's put our coefficients together, and we'll group our j's and our k's together. So of course 100 divided by 10 would give us 10. When your bases are the same and you're dividing, you subtract your exponents. So that's going to be 8 minus 10, always numerator minus denominator, and that answer goes in the numerator. And then here, 3 minus a negative 3, so again, numerator minus denominator, and answer goes in the numerator. All right, so 8 minus 10 is going to give us negative 2, and 3 minus a negative 3 would be 3 plus 3, so that's going to give us 6. Now, look how much simpler this is to raise to the third power than what this was. That's why we always want to simplify first before we apply our exponent. All right, so now I'm going to go through and I'm going to take 10 to the third, and j to the negative 2 to the third, and k to the 6 to the third. So 10 to the third, you can look on your chart and see is 1,000. Remember, when you have a power raised to a power, you're going to multiply those exponents, so that'll be negative 6, and then 6 times 3 will give us 18. The last thing we need to do, remember, is we're not allowed to leave a negative exponent in our answer, so we're going to use the reciprocal and write j to the negative 6 as 1 over j to the positive 6. So again, it was in the numerator, and we move it across that division bar to get rid of the negative sign. So this will be our final answer. All right, for 16, we were asked to rewrite 25 to the 1/2 as a radical. So remember that anything to the 1/2 is the same thing as square root. If it was to the 1/3, it would be cube root. If it was to the 1/4, it would be fourth root. But the primary one that we have worked with is when we have something to the 1/2, that's a square root. So square root of 25, of course, is 5. All right, so now we're moving into a section where we're working with our radicals. And with our radicals, we need to be sure that we always give our answer in simplest radical form. So for 72, the first thing I'm going to do is I'm going to prime factor that. So I know that 72 will simplify down to 2 times 36 because it's even. I know it's divisible by 2. 36 is even, so I know it's also divisible by 2. So 36 divided by 2 is 18. 18 is even, so it's also divisible by 2. So 2 times 9, and then 9 would be 3 times 3. So that gave us 2, 2, 2, 3, 3. So that's what you'll see right here. Okay, so remember with our radicals, what we're looking for is because there's no number here, we know that this is a square root. So to get rid of a square root, I need a square. So I would need 2 or a pair of things to be able to take them out from underneath the square root. So 2 squared, the square root of 2 squared, or the square root of 4 would give me 2, so I'm able to take that one out. The square root of 3 squared, or the square root of 9, is 3, so I'm able to take that one out. But this 2, there was only one of those, so I'm not able to take that out. So remember that you need a pair in order to be able to move it out from under this square root. So now we can combine the 2 and the 3, and we'll have 6 square roots of 2. All right, let's look at some more of those. All right, so for number 18, same idea. We've got square root of 5 times square root of 48. So if I look on my chart, neither one of these are perfect squares. And I do have a property that says that if I have 2 radicals that have the same index, so both of these are square roots, and they're being multiplied, then I can combine them underneath one radical. So before I do that, I want to break this 48 down and get it in its simplest terms. So I'm going to prime factor it. So again, 48 is even, it's divisible by 2, so that gives me 24. 24 is even, it's divisible by 2, that gives me 12. 12 is 2 times 6, and 6 is 2 times 3. So that gave us 2, 2, 2, 2, 3. So that's what you'll see right here. All right, so I only have 1 5 out of all of these. I only have 1 5, so I'm not going to be able to simplify that. But I do have a pair of 2's. So again, that's the square root of 2 squared, or the square root of 4. So that would be 2. And then the square root of 2 squared, or the square root of 4, that would be 2. And then the square root of 3, I have to leave there because remember, you have to have a pair to be able to bring it out from under that square root. All right, so 3 is going to stay underneath since there was only one of those. Now, I'm going to put together the things that are on the outside of the radical and the things that are still underneath the radical. And so 2 times 2 would give me 4. And square root of 3 times square root of 5 would give me square root of 15. All right, for number 9, we have a cube root. So first off, I'm going to break this apart into 2 separate pieces to make it easier to work with. So I'm going to do the cube root of 343 and the cube root of x cubed. All right, so cube root of 343, if you look on your little chart, you can see that 7 cubed is 343. And we know that the cube root and the cube are inverses of each other. They cancel each other out. So they'll cancel each other out and just leave me 7. Now, don't leave a square root or a radical or a cube root or anything like that on this. The cube root and the cube canceled out. You just have 7 left. You don't have a radical left. All right, same idea over here. Our cube root and our cube are going to cancel each other out, and that would just leave me with x, and so 7x. All right, then for number 20, again, I'm going to break this into smaller pieces just to make it easier to work with. So I'm going to take my coefficient, and then I'm going to put my x cubed. I'm going to write that as x squared times x. Y to the 4th, I'm going to write it as y squared times y squared. And z to the 6th, I'm going to write it as z squared times z squared times z squared. Now, when we go to simplify the square root of 400, let's come over here and let's look at that. I'm going to treat that like a totally separate problem because earlier on, this would have been a problem in itself, right? So remember we've talked about take it apart, take it one piece at a time, pull it off to the side. You can even cover the rest of this with a piece of paper and just focus on this one part. All right, so for 400, I'm going to rewrite that as 4 times 100, and then 4 would factor down to 2 times 2. 100 would be 10 times 10, and each of the 10s would be 2 times 5. So that gives me 2, 2, 2, 5, 2, 5. So that's what you'll see right here. All right, so we could take out a pair of 2's, that would be 2. Take out a pair of 2's, that would be 2. And take out a pair of 5's, that would be 5. So 2 times 2 would be 4 times 5 would be 20. Now, remember we talked about sometimes there's a faster, easier way to do that. If right here in this first step, when you were doing the square root of 400, if you saw that as the square root of 4 times the square root of 100, we know the square root of 4 is 2 and the square root of 100 is 10. So 2 times 10 would take you straight to that 20 as well. So either way, that will give us square root of 400 is 20. Now, for our x cubed, some of you prefer to write this as x times x times x. That's perfectly fine. You would pull out 2 x's to when you have a pair, you can pull one out, and then you have one left underneath that doesn't have a pair that's going to have to stay under the radical. Here we were writing it as x squared times x, so here's our pair right here. We know the square root of x squared is going to give us x, and then this square root of x would have to stay underneath. All right, so same idea here. If you'd rather write y times y times y times y and say that you've got a pair to pull one y out and you've got a pair to pull one y out, that's fine. Or you also can write that pair as y squared. So square root of y squared is y, square root of y squared is y. All right, same thing with our z's. Square root of z squared is z, square root of z squared is z, square root of z squared is z. So if I put together the things on the outside, that would be 20x y squared z to the third. And then the only thing left underneath the radical would be my square root of x. All right, we've seen several times already that it's usually faster and easier to simplify what's inside the parentheses or underneath the radical before we start doing any other operation. So let's go ahead and simplify 24 over 50. Both of those are divisible by 2, so that would give me 12 over 25. And then remember we have that property that says that if I have one quantity being divided by another under a radical, that I can break that into 2 separate pieces, into 2 separate radicals. So square root of 25 would be 5, and then square root of 12, if I prime factor that, I get 2 times 2 times 3. So I've got a pair of 2s, so I can pull one of those out, but I don't have a pair of 3s, so the 3 is going to have to stay underneath the radical. And so remember that you're not allowed to have a radical in the denominator, but it's perfectly fine to have one in the numerator as long as it is in its lowest terms. All right, then for 22, again, before we take the square root, let's simplify what's under our radical here. So I'm going to break this apart. 8 over 32 would simplify to be 1/4. Let's put our x's together. So when our bases are the same and we're dividing, we subtract our exponents. So 11 minus 5. And then same thing here. When our bases are the same, we're going to subtract our exponents. So 7 minus 3. So now I've got 11 minus 5 is going to give me x to the 6th, and 7 minus 3 is going to give me y to the 4th. So let's break that into separate pieces. The square root of 1 would be 1. The square root of 4 would be 2. And then for our x to the 6th, we can write that as x squared times x squared times x squared. And then our y to the 4th is y squared times y squared. So the square root of x squared is x. Square root of x squared is x. Square root of x squared is x. Square root of y squared is y. Square root of y squared is y. So let's put together what we have. So x times x times x would be x cubed, and y times y would be y squared.